One of the many uh, financial applications of calculus is a situation where we're talking about consumer and producer surplus. So going back to our econ classes, we know we've got these supply and demand curves. We've got demand, we've got supply. And here's a price, here's a quantity. So at particular quantities, consumers are willing to pay a certain price and producers are willing to sell at a particular price. And then we have this equilibrium point, a theoretical point at which the price that consumers are willing to pay and the price that producers are willing to sell for is the same. So at this point QP, we have the equilibrium quantity and price. So what's the price that they can agree to and what's that quantity that they can agree to? And what we can do is we can find this equilibrium point, and from there we can find consumer surplus and producer surplus. And here's what we're going to do. So let's say we're given some demand function. Say -3x plus 7, and a supply function 2x plus 2. So x is some quantity and the function is the price associated with that quantity. So to find the equilibrium point, as we've done with the past with solving systems of equations, what we want to do is just set the two functions equal to one another, and that will tell us where the two lines intersect, and that'll tell us where our equilibrium point is. So doing a little bit of algebra, we got adding, so we'll add 3x, subtract 2 on both sides, and so equilibrium quantity ends up being 1. To find the equilibrium price, we can either plug in x into the demand, or we can plug it into the supply function. And in each case, we got 4. So price is $4. So we now have the point, this equilibrium point QP, which equals 1, $4. From here, we can find consumer surplus and producer surplus. Consumer surplus is going to be that's kind of ugly. Let's look at that. I'm going to take the integral of the demand function minus QP. In this case, integral from 0 to 1 of negative 3x plus 7 minus q times p. Finding the integral, that will give us negative 3/2 x squared plus 7x evaluated between 0 and 1 minus 4. So negative 3/2 times 1 squared plus 7 times 1 minus negative 3/2 times 0 squared plus 7 times 0 minus 4, which gives us a value of 1.5 or $1.50. So this is going to be consumer surplus. To find producer surplus, the formula is QP minus the integral of the supply function. So 1 times 4 minus the integral from 0 to 1 of 2x plus 2 dx. So that's going to be 4 minus x squared plus 2x evaluated between 1 and 0. 4 minus 1 squared plus 2 times 1 minus 0 squared plus 2 times 0, or a value of 1 or $1, and that is the producer surplus. Equilibrium point. Find the equilibrium point. Using that Q and P, we simply plug in to our two formulas for consumer surplus and producer surplus. So consumer surplus, the integral of the excuse me, demand function minus QP, and for producer surplus, it's QP minus the integral of the supply function. So let's try another one. So we've got 1,000 minus 10x. That'll be our demand function. And then 250 plus 5x will be our supply function. Again, first step is we want to find the equilibrium point. So what we'll do is we'll set two equations equal to one another. So basically when they're supply and demand the same. Do a little algebra here. We got 750 equals 15x. And so x equals 50. So that's our equilibrium quantity. And then again, to find the equilibrium price, you can plug into the demand function, or we can plug into the supply function our equilibrium value of x, and we get 500. So our equilibrium point, QP, is $50 to $500. So at a price of $500, consumers are willing to buy 50 of a product, and producers are willing to sell 50 at that price. So to find our surpluses now, first for the consumer, there's our formula that integral of the demand function. So we've got 0 to q of 1000 minus 10x dx. And that will be 1000x minus 5x squared, evaluated from 0 to 50, minus q times p. So that's going to be 1000 times 50 minus 5 times 50 squared. And since the evaluation at 0 gives us 1000 times 0 and 5 times 0 squared, we'll just leave that off, minus 25,000 for a total of 12,500. So this is the consumer surplus. And then for our producer surplus, we've got the q times p minus the integral from 0 to 50 of 250 plus 5x dx, which gives us 25,000 minus 250x plus 5 halves x squared, evaluated from 0 to 50. So 25,000 minus 250 times 50 plus 5 halves 50 squared. Or 6250. And that is the producer surplus. So again, we find the equilibrium point, QP, by setting the demand and supply functions equal to one another, and then using those values of Q and P, we take the integral of the demand function, subtract QP to find the consumer surplus, and then we have QP minus the integral of the supply function to find producer surplus.